Hello, good morning, and a very warm welcome to Breakfast with Arab. It's great to see you all again. I hope you all had a lovely Easter break. My name is Farah, and I am the Marketing and Communications Leader for Buildings London. Good morning. And so to our speaker. Born in the same street he still lives in, Russell grew up in Chertsey, Surrey. He does actually live in Woking now, and it just so happens that the maternity hospital he was born in is at the end of his street. Russell's father was a toolmaker, and as a young boy, he was surrounded by making and engineering. Naturally adept at maths and physics, Russell decided to study civil engineering, as he was drawn to the scale of these mega projects. Graduating from Southampton University, Russell initially had no intention of joining a large firm, yet he was so inspired with his interview here at Arab that he decided to accept the offer of a job, and he stayed with us for over 30 years. Working as a structural engineer with Tony Fitzpatrick, one of his first projects was the ITN building in London. After 4.5 years, one evening in a pub, Russell was asked by Tony if he would like to go to Hong Kong for 3 months. 4 years later, he had worked on projects including the Hong Kong Stadium and City Plaza. Duly setting off to Sydney, he decided to try his hand at facade engineering. He stayed this time for 5 years, and this proved to be a pivotal point in his career. After Sydney, he chose to move to Singapore to start the facade team. During his 13 years in Singapore, Russell worked on a stunning array of buildings, including the National Library and South Beach Development, for which he was awarded Green Engineer of the Year in 2013, and the extraordinary Marina Bay stands. Russell returned to London in 2014 and has worked on an astonishing range of projects, and these include the sublime Gas Holders London at King's Cross for Argent, 1 Grosvenor Square, the London Spire over at Docklands, which when completed will be one of the tallest residential buildings in Europe, and of course the breathtaking roofs that kiss gently over the coal drops over at King's Cross. As our new leader for the Facade Design Group, I'm delighted to introduce the enigmatic Russell Cole, who will now take us through the looking glass. Thank you, everyone.
Thank you, Farah. Good morning, and thank you so much for making time to come and listen to me. As our industry continues to evolve, harnessing and embracing new technologies and materials, our buildings morph and adapt. And of course, our role as facade designers also change. I'm here to share my story with you. In the beginning, it was simple. A hole in a wall that supported the roof and the floors to let the air and light in. There might be a door or a shutter to keep the rain out, yet it was simple. Glass is a naturally occurring substance. It is disputed whether the Egyptians or the Mesopotamians developed techniques for making glass. It was not until the Romans started to develop new ways of making glass that it started to be used to create windows. After the fall of the Roman Empire, Venetian artisans kept the skills alive for glass making during the Dark Ages, in parallel with India and China. Techniques in chemistry of glass continued to evolve through the Middle Ages, and by the 1100s and 1200s, this led to the craze for stained glass windows. This trend of stained glass windows influenced the master builders of cathedrals to develop buttresses, flying buttresses, and other techniques for creating large areas of glazing. Venice at this time became famous for the quality of its glassware products. However, concerned about the dangers that dozens of glass furnaces posed to its crowded city, the Doges decided to move the glass industry out of the city to the outlying island of Murano, which of course is still famous for its glass ornaments and sculptures. And the technology for developing and manufacturing glass continued to evolve over the centuries. Over time, the crown glass technique became more prolific. During Tudor times, large areas of glazing were designed to create galleries that became the must-have feature for stately homes to impress visiting monarchs and their courts. A few decades on, lead glass was being developed in the UK, which ultimately led to crystalware. As the Industrial Revolution matured into the Victorian age, methods for producing glass windows continued to develop, with glass sheets cut from large blown cylinders becoming a new mass production technique. This technique supplied the acres of glass used for the construction of the revolutionary Crystal Palace. Mass production techniques in the 1800s used timber for window frames, with some use of wrought iron frames for industrial and transport buildings. In the US, larger buildings were being developed, where structural steel frames carried the building's weight in place of masonry walls. These allowed larger areas of glazing to be created. In the late 19th century, brick and stone were used to form the spandrels or solid sections of the wall, but they did not carry load. A similar form of construction continued through the skyscraper boom of the 1930s. With the advent of modernist architecture and with its elimination of decoration and focus on functionality, architects began to explore how glazing and facade design could create transparency, again splitting the facade from carrying loads in pursuit of a simplified aesthetic. This fashion led to large areas of glazing being created with minimal framing. Initially European style, the modernist aesthetic transferred at scale to New York and Chicago. Several trends came together after the Second World War to completely revolutionise glazing and facades. Architectural styles pulled together several new materials to develop the curtain wall. In the 1950s, Pilkingtons of St Helens developed float glass line, which is by far the most commonly used production process to this day. Aluminium had become increasingly common in the first half of the 20th century. It was not until various alloys were developed that it became a strong and ductile material that has become common in construction. In 1956, a patent was lodged in the US for warm extrusions, a technique that allowed large quantities of aluminium alloys to be extruded. One key advantage was that aluminium could be extruded into fine and precise shapes and tempered to give a higher strength, making it ideal for forming window sections. As a result, this rapidly supplanted bronze that had previously been used for high-end glazing. Given the challenges of high-rise construction, American manufacturers developed stick curtain wall systems. These used the third new component, widely available gaskets and seals, to form complete curtain wall systems. The next step in the evolution of curtain walling was the move from stick systems assembled on site to pre-assembled units completed in the factory. The advantage quickly became self-evident, with the speed of high-quality product on site a clear advantage. I could happily go on to telling you a detailed version of this story, highlighting the nuances of extrusion and gasket design, but Farah has asked me to spare you this pleasure. The drive for transparency continued, using new glass processing techniques on float glass. In the 1960s, glass fins were developed, and into the 1980s, as an element in the UK high-tech architecture, point support glazing evolved, famously developed by Peter Rice. And of course, we now have living facades with green walls and vertical greenery, very dramatic and ecologically beneficial for our cities. And then we witnessed the evolution of a new profession. Alongside the post-war development in facades, engineering consultancies as part of their broader service might have included advice on cladding systems. And some early facade engineering examples include the glazing to the Sydney Opera House and the cladding to the OCBC Bank in Singapore. As the facade systems continued to evolve in complexity and the role of forming a robust sealed envelope became, for a while, separated and less integrated with the rest of the building fabric, it became the realm of specialist subcontractors. Reliability of systems was not faultless, and clients began to become concerned about value for money from the specialists designing and supplying these elaborate systems. So, in the late 1980s, engineering consultancies began to offer facade consultancy services to independently design and advise on cladding and curtain wall systems. We are now, though, 21st century in a world of multi-faceted design. Projecting an identity for a development whilst creating comfort for those inside means that the walls and windows we have to work with have to work very hard in a relatively small space. The facade zone is only a few centimetres, but in that space the facade needs to be able to stand up, withstand wind and any earthquakes, accommodate the building moving behind, keep water and pollution out, insulate from the cold, let the warming sun and cooling breezes through, give views out and let the right amount of daylight in, cut noise from outside, yet people connect to birdsong and the sound of the street if desired, stop conversations and fire spreading through the building, and protect us from robbers and blasts. A tall order for walls and windows that should provide us with delight inside and out. Due to the myriad of performance requirements and aesthetic ambitions, a broad palette of materials and systems are being used to form our facades. At times it feels that metals and glass dominate, and these combine in a mind-boggling set of forms. Stone, bricks, concrete, insulation materials and timber all play their part, brought together by gaskets, seals, adhesives, fixings and brackets to form walls and windows. To work successfully in the field of facade design, we need to be masters of how the facade performs and the materials that are used. We also need to know how to bring these components together, mindful of fabrication, erection, installation, financing, contractors' roles and suppliers. Working in facades can be daunting. It feels a near encyclopedic knowledge is needed, as well as an understanding of the fundamentals. Yet, it is an intriguing and inspiring discipline where all our skills and hard work are on display for the world to see. And these are tested daily by the environment. And indeed, facades are always evolving. It is an area rich with innovation. New materials are continuously being offered to designers keen to find new aesthetic or the next wonder material. As a result, progress is quick and new norms are continuously being established. Yet somehow, the underlying systems and strategies are more constant. Keeping up to date is essential, as well as a keen sense of curiosity to challenge the best next thing that is being proposed on your project. I would advocate that we all need to start your facade design early. The facade clearly plays a key role in the design of any building. It keeps the outside out and the inside in, and also acts as a filter. We can choose how much energy, light, air, noise, and visibility we want to cross the boundary to the inside space. Although having its greatest impact on the perimeter zone of a building, a well-designed facade can have a greater impact on the whole and help create comfortable spaces. This, of course, helps with improving energy consumption and makes a big step towards achieving green targets. To have the biggest impact, though, it is best to design what the facade should be and what it should do before pen is put to paper and an aesthetic is fixed. Many decisions are made early in the building's design that define and set challenges for designers. We can make this easy for ourselves or difficult. Rather than apply sticking plasters, for example, to adopt a more expensive or difficult solution to make it work, we have the opportunity before the design is fixed and too much has been done to make some smart decisions that will save money, time and effort and may provide a better solution. Energy is the biggest facade design driver at the moment. Regulations and green rating schemes require building energy consumption to be as low as possible. Although there are minimum standards, very often energy models tell designers that much more insulation is needed than this standard might imply. As a result, walls become thicker, especially if large areas of glazing are also wanted. Poorly positioned large glazing might let the cold in during winter or cause people to overheat in the summer. Placing the right amount of glass in the right place could avoid triple heavy glazing and expensive coatings that reduce light transmission. Facades have a large ecological impact. Embodied carbon and the impact of extraction and fabrication processes are all issues. For example, aluminium extrusions can be relatively easy to recycle, but when they are first formed, huge amounts of energy are used. And the bauxite will have come from large open cast mines, potentially with a polluting runoff. Making extrusions and adding finishes all have energy and ecological impacts as well. exploring what materials to be used in a facade and developing a strategy is best done at the very earliest stages of a project. Perhaps timber frame facades could be used as an alternative, and yes, these are feasible in high-rise buildings. But only at the very start of a building, before any marks have been put down, can you ask questions to decide what the facade should be. Is the building shape and orientation right for views, daylight and the sun path? Should the form of the facade or the building be self-shading? What is the right proportion of windows to solid wall? How to make the most of daylight? What should facades be made of to reduce its ecological impact? And how could the facade be reused or recycled at the end of its life? These are all very fundamental questions that might drive performance, appearance and fabric of the facade in very different directions. Even if a particular aesthetic is maintained, an early assessment of these aspects may still have a significant impact. So, how might the future of facade design evolve? We have gone through some exciting years of harnessing the potential of software to imagine, design and define some spectacular building and facade forms. This exploration of form continues. Similarly, glass technology and the pursuit of transparency continues apace. We are now investigating how to embrace the latest generation of glass adhesives, and exactly how can large sheets of thin 2mm glass be used successfully in a building. These trends of transparency and new materials are well established. New approaches and ideas are always emerging. Some innovations, though, come to mind. There is a sense that the facade industry is finally harnessing recent digital developments. For us, having something quick and easy to use that can display and record information is the aim. Recently, we have used gaming software to develop tools that allow users to navigate around a digital twin of their facade. All sorts of design information, construction records, or progress photos can be loaded onto that digital twin. The key, though, is that they need to be easy to use for those of us that do not code or draw in digital space. Rather than an alternative to the BIM model, we see this as a practical way to access and interact with the information that these models contain. Our aim is that the digital twin, with all the information and records, will eventually be passed on to the building owner and those that operate and maintain the building. We also see that the design phase will make use of tools that both simplify and enrich the process. By combining different skills, analysis programs and IT platforms, we are developing interacting apps that allow designers to explore and design options whilst avoiding lengthy iterative loops. This example again makes use of gaming software to give quick and easy interface. It is intended to be the subject of a design discussion because it allows options to be quickly compared. It informs these discussions and allows decisions to be made. For instance, the analysis of one geometry is completed, and then, using the sliders provided, the designers can explore how the glass specification or window size can be modified to hit the energy transmission targets. New materials will continue to be developed. When it comes to glass, we have nearly reached the point where glass selectivity can no longer be improved. The only way to reduce energy coming in will be to reduce the amount of daylight as well. To avoid this and to get better performance from glazing in our facades, they are becoming responsive. In other words, they react to the conditions outside to suit the activities inside the building. You can say this approach has always been with us. Remember the shutters mentioned earlier. And blinds, Venetian or otherwise, have been common features for many years. Yet with improvements in motors, mechanisms, sensors and control systems, these can be taken to another level. Closed cavity facades essentially adopt this approach. In these, the responsive element is the blind in the cavity, deployed automatically by those sitting inside the building. But there are other ways as well. A few years ago, now we developed the huge umbrellas that are deployed on the Al Bahar Tower in Abu Dhabi, shading the building from the outside when needed. We understand these are still functioning well after several years in service in a challenging environment. More recently, we completed the gas holders at King's Cross. These residential towers sit within the restored and rebuilt Grade 1 listed gas holder frames, and their facades incorporate motorised shutters at the control of the residents. To protect the shutters from damage though, these are linked to wind sensors on the roof that will shut them down when certain wind speeds are reached. So how will the facade designer's role and focus change in the 21st century? The focus on environmental impact will become an increasing driver. It is vital and ultimately inescapable that the greenhouse effect will need to be addressed, and the facades we design need to play their part and respond to climate change. The ecological impact of the materials we choose to use will soon be influencing and driving our designs. Apart from counting and measuring the embodied carbon and water, assessing pollution and other impacts, we will also need to plan the future use of materials once they have served their purpose. It is inevitable that the role of the facade designer will continue to evolve and morph, and as more and more considerations will need to be addressed and balanced. Essentially, the facade designer will need to unpick the complexity of design and keep well informed. The key skill, though, will be the ability to create an enjoyable journey from concept to handover to operation and repurposing of the facade. This will be enabled through embracing and harnessing new tools and applying our intellect underpinned by our collective experience in the industry. Yet, for all this focus on performance and ecological impact, we all aspire that our buildings will have an identity, to take their place in the cityscape and to bring delight to their surroundings and to the people who pass by or walk inside to work, live and play. The facade designer will orchestrate the materials, systems and geometry to realise this vision. Thank you. Any questions? Thank you.
So I work in, I'm kind of looking at public realm and particularly focus on walking. And I was hearing one of the deputy mayors of Paris talking about when they design streets, they work on a kind of facade to facade basis across the streets, which when I've looked at transport design here, we just look at the kind of pavement to pavement, I suppose. So I just wonder how, whether you look at kind of the environment of walking through, so particularly the ground level, and if you have any good examples of how kind of facade design has kind of encouraged a great kind of walking environment.
Last year we gave some talks around cities alive. This looked very much at the way that facades and in this case greenery played their part in the streetscape. And it was found that you did need to be mindful of ways of managing how the different facades could interact. And what we found was that greenery placed in the first 2 stories of a street could have a big impact on reducing energy and improving the environment and reducing pollution. So yes, we do think about it. The other option is to create microclimate spaces close to facades, where people in the city can interact in sort of semi-public spaces. That would be the other area we would get into.
My question is about automated facades with automated louvers and shutters. Considering how fast technology progresses and changes, what is the estimated lifespan of all these shutters and louvers, and how much energy you need to maintain and look after and repair, considering traditional maybe masonry or stone facade? Yes,
it's certainly active systems are always going to be a little bit more, will have a lifespan that is different from, let's say, a traditional masonry facade. They will need to be maintained, but we are seeing that the reliability of motors and mechanisms is really improving. The Albahar example, that was put through some very rigorous testing over many, many cycles, and also subjected to sort of accelerated aging and all these sorts of things. So well-engineered systems can be developed, and technology is supporting that, but it would be daft for me not to say that you need to have in place a regime for maintaining and monitoring these systems and looking at them. The actual energy used to operate these things is actually quite small now. The scale of motors is coming down, driven by just miniaturization used in all of the devices around us. that's why I think these sorts of operable elements on the outsides of buildings will become more and more common as the time goes on.
Do you think building owners who develop building, they would be keen on investing in something that needs a lot of maintenance rather than having something built and just sell it and forget about it? How would you address this marketing issue?
So you go to gas holders, right? So the idea that people in those units have the ultimate control over privacy, shading, and how much light they choose to let into their apartments is actually a major selling feature on that development. I don't think heavily maintained, I wouldn't say that. They need maintenance, but then again, any glazing system needs to be cleaned and checked for robustness. Stevie?
I was just curious, I'm sure I've seen small examples of where you can actually change the properties of the glass itself, so it can go from kind of clear to opaque. I just wonder whether, do you see the future going away from the kind of mechanism that folds over the glass to actually changing the property of the glass itself?
So switchable glazing is definitely coming of age. There are more products becoming available. They're becoming available in larger sizes. The colour of those shades as they come across is changing as well. So it is an emerging technology. It's driven in part by all of those large screens we like to look at. That technology is filtering through into glass coatings and those sorts of things. So yes, that will be another option. That needs to be combined with performance coatings on glass as well. But that will become more plausible and feasible.
Yeah, Russell, great discussion, thank you. The complexity of the topic is very clear and evident from your presentation. But it's changing the dynamic between you as a facade consultant and the rest of the design team, particularly the architect, I would suggest. And I just wonder what your view is about that and how you get the early engagement with designers who perhaps don't see the need for that engagement, or maybe more importantly, the customer, the client, doesn't see the importance of that early engagement.
I think it feeds obviously to the points I was trying to make there, which is that the smart decisions that can really make a big impact and save a lot of money are best done before we've locked into too much. And I think it does take a bit of experience, but it certainly, that's why I like to emphasise it needs to be a journey with the architect and the client about, here's a whole bunch of this performance and technical stuff over here, but there's also got to be a design and something, an aesthetic and an identity as well emerging out of it. So I am very, very keen to find architects and clients who want to go on that journey. That's the motivation for talking today, actually, because it is something that needs to happen. The thing is, the impact of the facade is so big now, and it is so complex and so many things to resolve that we need to be thinking about it very early on in design. Bruce?
Very interesting, thanks. And just a brief touch on what was brought before. So we know glass is starting to become switchable and adaptable, and it's starting to change the way people design facades in terms of minimising the amount of external louvers, maintenance issues. What I'm finding when I'm talking to designers, and I'd just like to ask you what your opinion is, that we're starting to move away from traditional ideas about G-value percentages, which are all quantifiable, to talking about well-being and comfort of building occupiers and users, which is not yet quantifiable. Are you looking at ways to study those interactions?
Yeah, certainly. There has long been a recognition that daylight is very useful to our daily cycles and our well-being. So finding ways to look at the quality of daylight coming in and light levels is important. Of course, it's always got to be balanced out with too much glare and useful space and beneficial daylight. So that's why I normally talk about beneficial daylight. How to get parameters on it is very difficult. I think there's a lot of research emerging around wellness and light levels. But certainly I think building designers need to think about access to daylight. This trend towards very large floor plates seems counterintuitive because you might actually be impacting the productivity of people working on those floor plates. So access to daylight could be very important.
You made a point about expertise at some point in the evolution of the curtain walling line with the specialist subcontractors, and then moving back towards this, this new category of facade engineers. Where do you see the expertise in the industry now? Because I mean, 20 years ago it was with the Swiss and Germans, but do you see that coming up in other parts of the world?
Okay, so firstly, let me not say that the facade consultants have taken over the baton of leadership in this field. Very much, we are a discipline that's very integrated with its industry. So that we need to stay very close to producers of materials, designers of systems, suppliers, installers, because it's actually unpicking their world and what drives and what keeps them awake at night that we need to then convey to clients and architects and other people in the construction field. In terms of where's the interesting stuff coming from at the moment, I'd say there's a huge amount of advances being driven by people like Apple, who have been asking for bigger and bigger pieces of glass, acting in different ways, and that has made profound changes to the scale of glass and the materials that are being produced. So a lot of it is in Europe still, but you'll also see China and other Asian centres trying to also develop new processes and techniques. So as always though, it's great to work in Arup because you have access to our material specialists, because you've always got to have that scrutiny and curiosity to inquire about, well, is this new material robust and appropriate to be used for the next 20, 50 years on a building?
Thank you for your lecture. I work with urban design, and it's quite clear that the city changes, and in this evolving environment, how reflectance and the access to natural light would affect your concern with technology, because once you assess a available natural light access or reflectance from a particular situation, this can change. And how would this affect your research and your knowledge about what will happen with the building that will happen to prescribe a certain design for this existing condition?
I think this is obviously a challenge, right? So it's not just light and energy that might get changed from its neighbours. You can also have wind environment will change as well, which might even increase the load on your windows, these sorts of things. So, the neighbourliness of new developments, I don't know quite how that's best managed. Obviously, you at one end of the spectrum, you could put in lots of regulations about access to daylight and how much it should be reflected or blocked by a new building, but then the city would be ossified. So there is a balance there, but I think there needs to be some mechanisms for some reciprocal, for a new development to look at the impact on its neighbours. But I haven't any particular ideas on that, I'm afraid.
I'm interested to know sort of your view on the zero carbon building that obviously is the intention going forward in terms of the facade, and how you see that playing within that.
I think it's quite important. Obviously, there are lots of different definitions of zero carbon. Zero carbon in operation, I think, is a reasonable aspiration. The challenge for facades is actually when you start to say, well, no, it's the whole embodied carbon, right? And as I took the time to make a point about aluminium, there's a lot of energy locked in there, as well as glass as well. So I think it's zero carbon is one part of it, operation, but then I think we need to think about the circular economy and how to take those materials that are so expensive in terms of embodied carbon and water, etc., and continue to use them after they've been used for 20, 50 years on a building. So difficult field, but equally again, it goes to that thing about starting early. If you really want to tackle embodied impacts, then we need to make some decisions early about, well, Could we be using timber? Could we be using concrete, etc., etc.? Maybe one more question.
Jeff Taylor, Alma Kenter, Nasty Wicked Property Developer. My question goes to noise, not the noise you can keep out by a facade, but the noise a facade generates in its own right. As we go denser, because we'll need to go higher, that propensity is going to increase. One of the questions I ask of the design team is, will it whistle Dixie? Most of them don't understand what I'm talking about, but they soon get it. What we do CFD for the wind effect of buildings and orientations at ground level and across other buildings. Do you have any experience of assessing facades for the noise they generate simply by the wind impact?
So the reaction of the facade to wind and then stimulating noise or whistling, really difficult subject. Right? I've gone through many, we have a clause in our specification that says the facade shall not make noise or whistles, right? And Perma-Salisa will immediately jump on that and try and cross it out because they admit that they don't know enough about exactly what generates that noise. And we have to admit that, yes, there isn't a clear science around this. However, there are some established rules of thumbs and some things you don't do. And certainly, so the version that comes back is that there's a lot of things that people can do to attempt to mitigate and avoid that risk. I think if you're looking at very large, long, thin-spanned elements that could be potentially responsive, then you should definitely be doing something a bit more scientific and looking at, what are the resonant frequencies and what noise that might generate. But yes, it's an area where there isn't clear science. Equally, it's also difficult to develop and imagine tests where you can actually get a facade to make a sound or to make sure it doesn't make a sound. So difficult, but there is some knowledge out there. So I think with that we'll wrap up. Thank you very much.
Well, the facade needs to be a multifunctional thing. It needs to do more than one thing. We're a company which produces solar photovoltaic facades. So that's glass which produces electricity from daylight. But it also reduces heat gain into the building. It's also reducing noise gain into the building, glare, and all those other elements. So what you're trying to do at the end of the day with new urban regulations is make zero carbon buildings. You need to make buildings which don't use energy or are neutral on their energy consumption. And the really only way you can do that, given in an urban environment you have very little roof space, is to use the facade to also generate electricity. So that's what we're doing. The talk today was a very good example of the whole range of what a facade has to accomplish, and therefore how one needs to consider it early on in terms of its overall delivery.
Well, from my point of view as an urban designer, I would think as the facade is the utmost part of the building which is related to the open environment, it should take into account the neighborhood and how the neighborhood would affect that particular building facade. To measure this, it's a problem that can be sorted out, and I think this is one of the issues I think the industry should address to, the relationship between the building facade and its neighborhood. Here in London, you have been recently impacted by a sort of accident that happened with a car mirror and the building around. So the car had been affected by a building facade, not to speak to other buildings. So reflectance and also natural light accessibility for buildings according to new buildings is something that is an issue that should be tackled by city councils and building permissions. I think this is an important issue, but it's very difficult to predict this sort of impact. But I think legislations, urban regulations, should tackle this issue very soon. I don't know any municipality who really has developed parameters for assessing this issue, but I think this is coming. I think this will very soon be a part of our daily life.